Good morning, guys. So today what we're going to be going over is, well, let's start off by doing this. It's a simple little exercise that involves just numbers, right? So this is very similar to how the formula is going to look like today. So here, let's go ahead and multiply this. 5 times 5 times 3. So windows like this, there we go, so that I can have the calculator here. So 5 times 5 times 3. 5 times 5 times 3 gets me 75. There we go. 75 over 2 squared is 4. 75 divided by 4 is 18. Okay, so let's do the next one. Well, all we're doing is multiplying everything across, okay? 25 times 60 times 2 is 3,000. 10 squared. 10 times 10 is 100. 3,000 divided by 100 gets me 30. Okay? And now we're running into exponents. This is an 11. Here, let's make it a little bit. Oh, I was going to make it better, and I made it worse. Let's fix that. It just smudged on there 11. There you go. It's a little bit better. Okay, so let's ignore the times 10, and let's just multiply the numbers, since we learned that already, right? We learned how to multiply exponents. So in this case, I'm just going to multiply 2 times 4 times 6. 2 times 4 times 6. No, that's not right. 2 times 4 times 6. It was right. 48. And I'm going to do that, okay? I'm just going to bring that over. And here we have 6 times 10 to the negative 12. So let's just divide these two numbers here. 48 divided by 6. And that gives me 8. Eight times 10 to the, so here we have 11, and this should be 11 minus, and that's negative 12, right? When you minus a negative, you're actually adding those numbers. So here we have 11 plus 12 gets me 13. Okay. Okay, and there was just a little tiny mistake. This should be 23, not 13. Okay. Let me erase this here. Okay, so now let's look at this example here. We have 8 times 20 times 5. And let me just make it into a standard so it's not, there you go. 8 times 20 times 5, 800. And I'm going to leave the 6 there, okay? The exponent times 10 to the 6 over 8.22 times 10 to the negative 12. Let's erase this. Let's make some space. Okay, so now I am going to divide this. 800 divided by 8.22. So that's 800 divided by 8.22 gets me 97.3. Oh. times 10 to the, so here the exponent 6 and a negative 12. So this is actually 6 minus negative 12, right? So when you divide, you're supposed to kind of do that. And when you minus a negative, it actually becomes a positive, or you can just answer it in exactly the way you see it in the calculator. So if we do 6 minus 12 negative, see, it adds them up, right? 18. Now remember here, the decimal is in the wrong spot. It has to be a number, a decimal, and then a number. So we're moving the decimal over to the left, and if we do a quick little number line here like this, if you move to the left, you're going to get bigger. If you move to the right, you're going to get smaller. Since we moved the decimal to the left, we're going to get bigger, okay? And we just moved it once, so that should be 19. Okay, all right, so let's move on to the... So this is how the formula is going to be, exactly like this. You can do this, therefore you can do the formula. Now what you can do with this example here, which is not loading, but it will. Well, let's just look at the example right here on the screen. So what I would suggest that you do is to work out these problems. Here we go. Work out number 5 and number 6. You should pause the video here and work this out, and this is the answer, okay? If you don't get this as the answer, then well, I'm gonna go over it, okay? But I would highly suggest that you pause the video and you work on this. Don't just copy the notes, because then that defeats the whole purpose of learning, right? Then when you get to the problems, you're gonna be like, wait, how do I do this, right? And here is your chance, okay? So I would suggest you pause the video here. But what I'm going to do is I'm going to go ahead and work this out. So these numbers that I'm underlining, I'm going to multiply them just the way it says to multiply. 6.67, 6.67 times 4 times, what was the other number, 5? Times 5. That gives me 133.4. 133.4. Now notice this, the 10 to the negative 11, that has to just stay there. Let's just keep it, okay? Because there's nothing else here. 3.2 to the 4 times, that should be a times 10 to the 4. So now, let us divide this right here, 133.4. 133.4. It's always good to clear everything out just in case. Divided by 3.2, 41.68 times 10 to the, and then the exponents we learned, all you have to do with the exponents is subtract them. So here this is saying negative 11 minus 4. Negative 11 minus 4 gets me a negative 15. Okay, negative 15. Now I want you to notice here 41.6, 4.1. Okay, I know that, I mean, this one should have a 6 here, but that's okay. But notice the exponent, it's wrong, right? Here the answer is 14 and here it's 15. So now you want to ask, well, why is the answer wrong if I did everything right? Well, remember, we do have to move the decimal over to make it a number, a decimal, and then a number, right? So since we move the decimal to the left, if we do a quick number line here, let's do a number line. If you move to the left, you're going to get bigger. Let's change the color. You're going to get bigger. If you move to the right, you're going to get smaller. Okay? So if you do just, you know, just a quick little number line here. Since we move the decimal to the left, we are going to get larger, right? We're going to the left. So if this was at negative 15, if you move it to the left, the next number should be negative 14, right? And that's how we end up arriving at the same exact answer. Okay? Let me erase this so that I can have some more room. Okay, so now let's start multiplying 3.8 times 2 times 6.2. 3.8 times 2 times 6.2. 47.12. We do have exponents, so now I want you to notice this 3 and this 2. Since we are multiplying everything, what do we do with the exponents? When we multiply everything, we add them. Okay? 3 plus 2 is 5. And now we're going to have to divide this right here, right? 47.12. 47.12 divided by 7.5 gets me 6.2. I'm going to put it over here. Okay. So now the exponents 5 minus 11, 5 minus, that minus is always there, right? So I would suggest that maybe you do this, okay? We are subtracting, but then there's also another negative, so you should have a minus, a negative, okay? So here we have 5 minus negative 11. 5 minus negative 11 gets me 16. Okay, now I want you to notice, yeah, it was a little off, but that's okay. I mean, I might have, on the calculator, if you have a calculator that has all the numbers, if you use more numbers, it's going to be off by just a little bit, but that's okay. Still, the exponent is still the same, it's just off by from 0.2 to 0.5, so that's fine. That's okay, as long as it's close enough, right? Okay, now let's go into the formulas. So you're going to copy this on the right side, okay? So all objects are attracted to each other the same way the plus and minus ends of a magnet are attracted. So how much attraction is there? It is according to the size and distance between the objects. So believe it or not, everything has gravity, okay? Even you. Now that number, the amount of gravity is actually so tiny. All objects have gravity, okay? So, but it's just so tiny that it's almost like if it's not even there. In order for gravity to really have an effect on anything, it has to be really, really large, such as planets, right? That's how something has to be in order for gravity to affect everything. So it is dependent on how large the object is and the distance, okay? So everything kind of wants to just be, in a way, stuck together. Maybe that's how the reason the Big Bang happened, right? So everything was the size of a little grain of salt or whatever, and the whole universe was together, and then eventually it just exploded and it created everything you see around you, okay? So, okay, you're going to copy this on the left side. Let me erase all of this part. So this is the formula that we are using. So in order to find how much force there is between objects, or if we want to find the mass of an object, how big something is, or how far it is, that's the radius, we use this formula. And G is always going to be this number, 6.67 times 10 to the negative 11. So when we are writing this formula, G is always that. That's the universal constant for gravity. This is such a very, very tiny number. It's going to be, if we move the decimal over to the left 11 times, it's going to be 0.0000000000667, right? It's really small number. That's how much gravity everything has. Like I said, unless you have a very large enough object, then you will experience a pull towards that object. So now, what we need to do is we need to solve for how much force there is according to this object. So here, notice they are giving us the mass, okay? And the masses are going to be plugged here. So this is our first mass. And then this one right here is our second mass. So what you should do is anytime you have exponents is to put them like this, okay? You want to put them in parentheses so that it can kind of separate it from other numbers. There we go, it's a little bit better. And this, anytime you see meters, that is a radius, okay? So this is 6.38 times 10 to the 6 squared. Okay, so now what we're going to do is we are going to multiply the numbers. 6.67 times 50 times 5.97. Just like we did earlier, okay? Don't let the formula throw you off. We just did something like this. Let me show you. I'll prove it to you. We just see right here. Then we just did that, okay? So 6.67 times 50 times 5.97. And I get a very large number, right? 1990. I'll just say 1990. Okay. All right, so now what we need to take care of, is the exponents, right? Yeah, let's do the exponents. Times 10 to the, so here we are multiplying exponents. When you multiply exponents, you add them. So negative 11 plus 23 gets me 12. Okay, so now this bottom part, what we're going to do is this, we're going to square it. 6.38, okay? So 6.38 times 6.38 gets me 40.7. Now the exponents, this 6 and this 2, now notice when we're multiplying exponents, we add them. Here, we have an exponent and an exponent. So in this case, we would actually multiply these two exponents, okay? So here you would add them, but here, this is this number squared, okay? When you're doing that, you actually multiply these numbers. So this would be a 12. Okay? So now what I'm going to do is I will divide that. 1990 divided by 40.7. That gives me 48.8. Now I want you to notice this number. Here we have a 12. And here we have a 12. A 12 and a 12, it's actually 0. So we're actually not going to put an exponent here. Okay. Okay, let's go to the next example. So here we are. erase this so that we can see how the numbers fit in. So remember, for G is always going to be this number. Okay. And notice here they're giving us a mass of 2 and another mass. And this is supposed to be our radius. 6.4 times 10 to the 6th. And then this is supposed to be squared, like that. Okay. So let's multiply like normally. 6.67 times 2 times 30. 6.67 times 2 times 30. That gives me 400. And since there were no other exponents, we just leave that exponent there. Okay. Now this part right here is probably the new part. This, you are going to square that. 6.4 squared. 6.4 times 6.4. 40.96. And now these exponents, we're actually going to multiply them. Since we're squaring this, you actually multiply them. Okay? So that should be a 12. So now we're going to do 400 divided by 40.96. 400 divided by 40.96. 9.7. Okay. And the exponents, what do we do with the exponents? We subtract them, right? Negative 11 minus 12. So let's just go through it. Negative 11 minus 12 gets me 23. And the units for force are always newtons, so we're going to put a big N there. And there you go, that's our answer for this example. Okay. Okay, so let me just show you really quickly. Now, what if you get a problem like this, where they give you the newtons, right? They give you all of this, and you need to solve for m. Well, you're going to do the same exact thing. You're going to multiply here 5 times 8, right? So 5 times 8, right? 40. You know what? What you need to do first is this part. So let's wait on that. We need to do this part first. We need to do 8 squared. 8 times 8, 64. And these exponents we're going to multiply. 4 times 2 is 8. Okay, so let's erase this. So now we're left with this. Okay, so okay, now we can do 5 times 64. 5 times 64. 320. And these, since we're multiplying, we're going to add them up. 8, 9, 10, 11. And you know what? I'm not going to rewrite all that. Let's just be a little bit more efficient on that. So let's multiply this times 2. 6.67. 6.67 times 2. 13. That stays there. See, we have this m here. So what are we going to do? We're going to divide this whole thing, and we're going to move it to the other side. Times 10 to the negative 11. So now let's divide this. 320 times 13. I'm sorry, 320 divided by 13. 24.6. 24.6. The exponents, we are going to subtract them. 11 minus negative 11, right? So 11 minus negative 11. Let's try that out. 11 minus negative 11 gives me 22. And it's 22. 22, okay? And since this was a mass, right, we were solving for mass, this canceled. This should be kilograms, okay? So you're solving everything normally, okay? Don't do anything different. Just do everything normally, okay? Now, if you were solving for like r squared, let me just make up some numbers really quick. 10 times 2 equals 6.67 to the negative 11, and they give me these other numbers. I don't know, I'm gonna make it really quick. 3 into r squared, right? So how would you solve this? Same thing, okay? Same exact thing. Cross multiply. And my computer froze. It's too much for the computer. There he goes. There it goes, there it goes, okay. Okay, r squared equals, we're just doing everything the same, right? Normally. So, you know what, let's put this in parentheses. The computer's freezing a little bit, but that's okay. 6.67 times 3 times 2. 40. 40 times 10 to the negative 11. Okay. And here we're going to end up dividing, right? Yeah, r squared equals 40 divided by 2. Well, that's easy. That's 20, right? And then the exponents, negative 11 minus 2. Gets me 13. Negative 13. Okay, so now when you're square rooting numbers, what you need to do is, this is a little like trick, okay? This number, we need to make it an even number. So how do we do that? Well, we can move the decimal either to the right or to the left. It's not gonna matter. But if we do a number line, 0, 1, 2, 3, 2, negative 1, negative 2. So we have negative 13 over here. If we go this way, it's going to turn into a negative 2, right? Negative 12, 11, negative 10, negative 9, negative 8, negative 2, negative 1, 0, 1, 2. So we're actually getting larger, right? So we're going to the left. So from 13, it's going to turn into, we're going to move it over, 2.0 times 10 to the negative 12. Since we moved it to the left, it becomes a negative 12. This is why, okay? We're going this way. So how do you do the square root of a scientific notation number? Well, like normal, let's do the square root of 2. Square root of 2, and there you go, 1.4. Okay, so 1.4. Now, how do we do the square root of an exponent? Well, you actually cut that in half. Okay, so if you remember on these other problems that we were working on, here where I was saying we're multiplying, 6 times 2 was 12, right? We ended up getting 12 when we multiply an exponent. Well, to get rid of an exponent here, we're multiplying, so we're gonna do the opposite. So on a square root, you actually don't multiply, you divide, you cut that in half. So this would be times 10 to the negative 6. Okay. So there you go, all possible answers, all possible ways of you're gonna see a problem like this with gravitational attraction, okay? So moving on to other stuff. So this slide just explains the attraction, gravitational attraction of between two objects. So if they are further away than the original spot, it's going to get 1 over r squared weaker. The r squared is the radius, how far apart it is. Okay, so if you have an object from here to here, let's say this is the radius. If it's twice as far away, how much weaker will the attraction be? It's not going to be twice as weaker or half as weaker. It's going to be 1 over 2 squared. Okay, so r, whatever r is, okay, if you move it twice as far away, you're going to square that. So it's actually 1/4 weaker. So if an object was originally here and here, if it was moved 3 times as far away, so picture magnets, right? If you have a magnet here, the closer the magnets are, the more they're going to get stuck together, right? So how do we measure how much weaker the attraction is between a magnet from here and here? And if it was twice as far away, it's not going to be twice as weaker or half as weaker. It's going to be 1 over r squared, so 1/9 weaker. Okay, so this one, for example, 1 over 4 squared, 1/16 weaker. That's how much weaker it ends up being from the original spot. Okay, if that somewhat makes sense. Well, if you increase the attraction of an object, how do you increase the magnets? If you have two magnets and they're far apart, how do you increase their attraction? There's two ways. You can move them closer, okay? Or if there's a way that the masses will become larger, then they're going to be more attracted to each other, right? So if you have a magnet that's like this, and let's say you replace this small magnet right here with an even bigger magnet, then yes, the attraction is going to be greater, okay? So this is just helping us understand the attraction between gravitational attraction of objects. You either move them closer, or if, I mean, it's going to be impossible for you to swap a planet and put another planet in there, but they still use that to help us like do theoretical explanations of like stars and black holes. And there's always this case of people saying, well, what happened if, you know, if Jupiter, for example, it just suddenly didn't exist? What would happen to our universe? Or what would happen to the sun if it just disappeared one day? Which, I mean, that's never going to happen. But it's just stuff that helps us understand the natural world around us, okay? All right. And the last thing that we have to go over is this part. So you might want to copy this like on the left side as well. And I need to erase the answers because just having the answers there, I find it as we write stuff down, it's easier to follow. And when it's just laid out there, we're just copying it. We're not really learning, right? We're not internalizing everything that is being told to us. So you might want to copy this on the left side of your notes, okay? Okay, so if you weighed 800 newtons on Earth and you travel to planet X, and that planet has a mass 3 times that of Earth, but a radius 2 times as large, what would be your new weight in newtons? So since gravity affects everything, this helps us determine what would happen if you went to another planet, because your weight is going to be different, right? If you go to Mars, for example, or the moon, the gravity in the moon is 1/6 that of Earth. Since it's smaller, you would weigh 1/6 less. So just to give you kind of a quick idea, let's say you weighed 200 pounds, okay, here on Earth. If you went to the moon, which is 1/6 the gravity of Earth, we would actually divide that by 6. You would weigh 33 pounds. Oh my gosh, isn't that crazy? It's really crazy, right? So if you think about it, if you went to the moon, and let's say we sent a bodybuilder up there that just really can lift, let's say they can squat 1,000 pounds, okay? It's the opposite. So here, if they are lifting that much here on Earth, they would actually be able to squat 6,000 pounds. So imagine an astronaut in Mars with a car on their back, and they're just, walking around with it like if they're a superhero, right? Like Superman or whatever. That'd be really cool to see, going to another planet and be able to lift a whole bunch of stuff. And that's the whole point of like Superman. He came from a planet that was larger than Earth, and when he came to our smaller planet, uh, he was actually stronger. So that is somewhat true. And the comics explain, oh, it's the sun as well gives him the power. He was in a Krypton. Planet Krypton had a red sun, whereas we have a yellow sun, and the yellow sun gives him more power. Actually, I mean that's not true. That's if you go to another planet, there's three different colors of stars. There's red, there's yellow, and then there's blue, which blue is the hottest, and red is the warmest. If you want to kind of look at it, it's not as hot. But anyway, that's actually not true. The sun part, the gravity part is somewhat true, But anyway, so here, how would you solve for this to find your new weight? Well, first of all, we're gonna write down our weight, and it's 3 times the mass. So I'm gonna multiply that by 3, and that gives me 2,400. That's my new weight, okay, in newtons. Just like we have, let's say 150 pounds. If you convert that to kilograms, I think it's like 72 or 74 kilograms. If it's in newtons, we can convert that to newtons by multiplying this times 9.8. Here, let me just do that really quick. 72 times 9.8, because of the gravity here, that's 708 newtons. So this is just a different form of weight, okay? 800 newtons. So now what we're going to do here to find our new weight is, it says the radius was 2 times as large. So we're going to use the 1 over r squared, which is what we learned up here, right? 1 over r squared. So 1 over 2 squared, which is 2,400, times 1/4. I mean, if you do that, 1 divided by 4 is 0.25. 24 times 0.25, 2,400. 2,400 times 0.25 gives me 600. So that would be my new mass, okay? 600. So here, let's do another example. So here we have 530 newtons. It's 5, we go to another planet that's 5 times as large. So 530 times 5 is 2650. And the radius is 1/4 times as large, times 1 over 4 squared, which is 1 over 16, which is 1 divided by 16, 0.0625. 2650 times 0.0625 gives me 165. Okay. So that's how we use that formula as well. And there we go. There we have how to solve for gravitational attraction. Once we get newtons, let me go into an example. Once we figure out the answer, right, and we get our newtons, that's going to be able to tell us if it's a large enough object where, let's say there's like an asteroid in outer space. Like, I don't know if you guys have ever seen that movie. What's the name of the movie? There's a movie with an asteroid, and they land on it and so on, and they try to break it apart because it's going to hit Earth and so on. So this will kind of let us know how much gravity there is. Will you be able to like walk on it and so on, or a planet? and that's the newtons. Once we have that, then it can tell us other stuff. It can tell us, well, how much will you weigh? If you land a rocket on there, on that planet, will the fuel that we have, how much fuel do we need to have in order to blast off from that planet, so that we won't be stuck there. And so it tells us all sorts of stuff. But I mean, this is kind of the most basic of the gravitational attraction formula. Okay.